So in this video we are again going to discuss some examples about generation of grammar for a given language. We are discussing it again and again as we have to introduce more and more examples so that in case of competitive exams you get more clearer concepts if you have seen more solved examples. So come, let's begin it. So consider this example. You have to generate a grammar that will generate this language such that all the strings in the language are a combination of A and B, and each string contains more A's. This is the point of concentration, more A's than B's. That is, number of A's are more than number of B's. So first most important point you have to keep in mind while solving a question like this in which it is written that more A's than B's is, you have to introduce a production in which the string terminates at A. Terminates at A means we have to make a production that will introduce a terminal A. If you write a production that will introduce a terminal B, it will deliberately make your machine or your grammar to generate a string that will have one extra B, because whenever you will terminate a string, for terminating you will use a terminal only. Suppose if we use terminal B for terminating, you will get one extra B which is not required. We require one extra A. Therefore we have to make the productions that will terminate the string with terminal A only. So we can make a production like S derives A. This will take only one string, that is A only. A is only a string in which there is no B and only one A. Number of A's are more than number of B's. So, or we can take AS such that in the place of S we substitute A again, we will get 2A's. 2A's is also a string in which there is 0 B's and 2A's. Or you can take a production like SA, you can replace this S with AS, then you will get ASA, and replace this S with A, you will get AAA, which is also a valid string in which there are 0 B's and 3 A's. So these productions A, AS and SA are restricting our grammar, the production rules, to specific number of A's. By increasing the number of A's on terminating a string, we can make more A's than number of B's. Now we have to substitute some B's also. In place of some start symbol, we have to substitute some B's also, because some strings should exist with B also, such that there are more number of A's and B's. For that we take a production like S derives BSS, SBS or SSB. In place of this S and this S, we can substitute anything from this productions or from this productions. One thing is of concentration, that we will stop only by substituting a terminal A, because we don't have any other terminal that can stop our string. In the last we have to substitute somewhere this A that will increase the number of A's in our string. Suppose consider the string as SSB. We are taking this production, then this S can be replaced with SBS again, SBS, and this is also SBS, and this is B. Now this S, this S, this S and this S can be replaced using AS, ASB, AS, ASB, ASB. Now this S, this S, this S, this S have to be replaced with this terminal A. There is no other option. There is no terminal B that can replace that S. As we have introduced this production, which is most important production, S derives A, this will terminate the string here, AAB, AAA, B. Count 1, 2, 3, 4, 5, 6, 7, 8. There are 8 A's and only 3 B's. Number of A's are more than number of B's. So these kind of production help us to gain more number of A's than more number of B's. But with these production we can introduce many B's, any number of B's. With these productions we can restrict our production to A's only, and finally terminate any string using this only one terminating production, that is S derives terminal A. So I hope so this is clear to you. Now consider this example. We have to generate a grammar for this language such that every string in this language is a combination of A and B, such that there are more B's than A's. In our previous example it was more A's than B's, now it is more B's than A's. So more B's than A's, that means we have to introduce a production like this that will finally terminate our string wherever we are. Finally we have to terminate using S derives B only, or string can be BS such that this S can be recursively substituted with any number of B's, or SB, similar for this S, any number of B's can be substituted. Or if we need to introduce A's in this production, then we can have S derives ASS, SAS, or SSA. Any number of A's can be substituted using this production, and finally you will have to terminate using this B only. That will make your string to have more B's than more A's. Consider one example. We write S derives SAS, suppose SAS. Substitute this S with ASS, ASS, ASS. Now these four S can be substituted using BS, A, BS, BS, AA, BS, BS. Now this S can be substituted using this B only to terminate the string A, B, 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 A, B, 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 B. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 B's and 3 A's. So there are more B's than A's. I hope so this example is also clear to you. This is the important production that will make our string terminate, and the terminal that will make our string to terminate will help us to gain more number of that terminals only. In case we have more A's, we write a production like S derives A, AS, SA. If we have more number of B's, we write production like S derives B, BS, and SB. I hope so it is clear to you. So consider this example. We have to generate a grammar for this language such that each string in this language is a combination of A and B, such that each string has unequal number of A and B. Now if you think it wisely, unequal number of A and B means either number of A's are more than B's, or number of B's are more than A. If number of A's are more than B, then also it will unequal number of A and B. If number of B's are more, then it will also be unequal number of A's and B's. So if you remember, we have already discussed these two examples. The previous two examples were these two only. Number of A's are more and number of B's are more. So in that example, we gained the productions like S derives A, AS, SA, S derives SSB, SBS, BSS. These productions were for more A's. Why? Because we are terminating on A here. Or the productions were S derives B, BS, SB, such that S derives SSA, SAS, ASS. These productions were for more B's. So this example is a combination of these two. Then only we will get unequal number of A's and B's. Now how to make these two productions combine? For this S, suppose we replace it by S1, 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 S1 and S1. And for this S, we say we replace it by S2, 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 S2 and S2. Now for more A's, the start symbol is S1, and for more B's, the start symbol is S2. And for unequal number of A and B, we take the start symbol as S, such that it either derives S1 or it either derives S2. And S1 is this only, AS1 or S1A, or S1 derives S1 S1b, S1b S1, b S1 S1, and S2 is having productions like b b S2, S2b, or S2 derives S2 S2a, S2a S2, a S2 S2. So you can in the starting take S1, or you can in the starting take S2 and then produce the string. You will always get an equal number of A's and B's. We have only done the combination of two examples and we have got our result for this third example. I hope so this is also clear to you. Now you have to generate the grammar also. How to generate the grammar? Just write the production rules in the form of the definition of grammar, that is NTSP. Grammar is non-terminals are S, S1, S2 only. Terminals are A, B. Start symbol is main. You have to take the main start symbol always. Other are non-terminals, but start symbol is S only. And the production rules are P, such that this P consists of these 5 production rules. I hope so this example of construction of grammar is clear to you. In the place of P, you have to write the production rules. Here I am pointing only towards them. So this was our example. So I hope so whatever example I have taken in this video are clear to you, and now you are fluent in generation of grammars for a given language. If you liked our video, please hit the like button, please share it with your friends, and if you have not subscribed to our channel yet, please hit the subscribe button also. And if you want to see our latest uploads and full playlist of theory and automata and computation, the links of the playlist and the video are flashed on the screen. You can check it out from there. Thank you.